Hello, welcome to the Injectables tutorial. This session is a demo of the Subcutaneous module in GastroPlus, in which you will learn how to set up a subcutaneous model. First, let's get acquainted with this model by going through the views in the navigation pane. In the observed data view, we can see that we have exposure data for intravenous administration, oral administration, and subcutaneous. In the compounds view, we have two compounds, one created by EDMET predictor import and the other one that has some measured properties. Going through to the dosing view, we have an immediate release oral tablet formulation as well as an IV bolus. In the physiologies, we see that the 85.53 kilogram human fasted physiology has a pair physiology associated with it. In the pharmacokinetics view, we can see the PBPK model for this physiology and compound pair. Let's run the IV simulation for midazolam. We will put this graph in a log scale by expanding the plot settings, coming to the dependent axis and changing from linear auto to logarithmic. I'll collapse this panel, and we can see that we have a reasonable fit to the observed data. Next, let's set up a subcutaneous model. Navigate to the dosing view, and in the formulation panel, we will click on Add, and we will name this formulation Subcutaneous Solution Abdomen. We'll change the route to subcutaneous, the release to immediate, the dose form to solution, and the location to abdomen. We will now expand the dosing schedule panel and click on Add to create a new dosing schedule. I will name this dosing schedule 8.627 milligram subcutaneous solution abdomen. I will link the formulation we just created. The dose amount is 8.627 milligrams, and the dose volume is 1.5 ml. Moving to the physiologies view, we will make sure that the 85.53 human fasted physiology is selected. I will collapse the pair panel and click on the toggle to turn the subcutaneous module on. In the Add Tissue dropdown, I will select the abdomen. The abdomen administration site will appear in the diagram. Here in the compound subpanel, we will change the fraction unbound to 0.028, which corresponds to the value estimated for adipose fraction unbound in tissue in the PBPK model. If we come to the PBPK model and look at the adipose tissue, we see that the Kp is 1.422, which is the Kp that we have for the abdomen, and the fraction unbound in tissue 0.028. And here we have inputted the value of 0.028. We'll save the project and navigate to the simulations view. We'll now create a new simulation by clicking on Add, and we will name the simulation midazolam hacking subcutaneous. In the drug administration panel, we will set the compound to midazolam. It's already set as midazolam. We will choose the dose schedule that we created for the subcutaneous solution, change the physiology schedule to the 85 kilogram human fasted, and change the pharmacokinetic model to PBPK. We can clear these messages up top by clicking on Done. And next, we will link the observed data under Compound Settings panel. Scroll down all the way to Observed Data panel, and here we can select the midazolam sub-Q packing exposure group. We also need to turn on the subcutaneous under additional dosage routes panel. We will once again turn the module on in the simulations view and expand the subcutaneous panel. Here, I'm going to click on Add Tissue Location and select the abdomen location. I'll update the effective depot volume to 12 ml. Click on Check Warnings and run a simulation. We can see that the Cmax was not properly captured by the model. Let's explore the effect of the subcutaneous partition coefficient on the drug appearance in plasma after subcutaneous administration. We will navigate back to the physiologies view, select the abdomen, and here we will change the Kp from 1.422 to 0.8. We'll navigate to the simulations view again and run the midazolam packing subcutaneous simulation, which is now using that updated Kp. Notice now that the simulated Cmax is very close to the observed value. The Kp at the subcutaneous injection site is expected to be the same as the Kp for the adipose compartment in the PBPK model. So now we will explore this change in the PBPK model by navigating back to pharmacokinetics view and changing the Kp for the adipose from 1.422 to 0.8. We now need to run the intravenous simulation to assess the fit. Going back to simulations view, and I will select the intravenous simulation and run once again. Again, I will set this to a log scale and collapse the plot settings panel. Here, I can see that the adjustment actually still resulted in a good fit for the IV dose. If I go back to simulations and run the subcutaneous simulation once again, I can see that for the subcutaneous simulation, the model also accurately captures the observed data. This brings us to the end of the subcutaneous tutorial.